let's go to the just bullet point. We basically discuss some examples, some areas where we see machine learning in our day-to-day life. Then we created a notion of understanding between how machine learning is different from traditional programming. We discussed some examples where the problem is capable of getting solved by traditional programming, or where some problems are getting solved by machine learning. We had the clear understanding of these two, and then we formulate the equation sort of thing where how a traditional programming is different from a machine learning programming. We understand this aspect, and finally we try to understand what actually the machine learning is, the understanding of data output programming function, basically the y hat or the function which tends towards the actual y. And then we see categories of machine learning programming. So we discuss on a very high level how what is supervised machine learning algorithm. We looked some example of that. Then we also try to understand about unsupervised and reinforcement machine learning. So I'll just again give you a one-liner summary. So basically, when we solve any problem where you got data, data means you got future. I multiple time I use the example of house price rent on the last class. So suppose you are supposed to find, predict or forecast the price of the house rent in that locality. Then you got data such as the area of the locality, the number of rooms in that house, number of balconies, what is the location. These are the features which are known as the data or independent variables. And then there are the y hat, which is the actual values. So if you are provided with the data and the output, such problems are comes under the category of supervised, where you know that this is my data inputs and these are the corresponding ground truth. When such sets are provided to you, that problems are getting solved and called as supervised. But there are some scenarios where you just got the data, you do not have any actual ground truth or true values corresponding to that. So for example, if you're working into an area or a cluster, maybe some city, you are given the task of breaking the city into some groups, each group having some dedicated specifications. Or for example, you're working into a bank domain, as a new employee, you are given the task of dividing all the customer into maybe say three categories: a bad customer, good customer, or an average customer. So this is the only data provided to you. Now you are supposed to group them. No other information is provided to you. Then such problems are getting solved by unsupervised, where you know the data, what is the characteristics of the customers, but you preemptively you do not know this customer is belong to category one, two, three. Then such problems are unsupervised. And thirdly, we discuss the reinforcement machine learning. Uh, Here, the good example is of ADAS when a car is trying to adapt into some environment. So these problems are reinforcement, where you have the environment where your car is an agent, and then agent is supposed to learn which direction to take, whether it's to take left direction, right direction, and based on the decision it takes during that moment, it is penalized or rewarded. So if a car is supposed to take a right direction, it takes the right direction, it is rewarded. But if it takes some decision which is not right, it would be penalized. So basically, over multiple iterations of right and wrong, a machine learning model is created, reinforced based on the environment in which the agent, so to say, here the example is the car is moving. But this is discussed on a very good level on that day. So yeah, now today's session, as I mentioned in the previous class, we're gonna try to understand the basics of Python, uh, s- because in future we're gonna do a couple of exercises of using machine learning algorithm. We're gonna do it from very starting till the end. Basically, the whole pipeline which you are seeing here, we're gonna do that. We're gonna process our data, training, model inferences. For that, we generally work with the Python, and a few of you has no understanding of Python. Therefore, I would be discussing the basics of Python. My goal is that in future, when you're gonna work with the Python, you can refer this Python basics Jupyter notebook, this Python basics anytime, and it would be sufficient to solve all the problems. So now, most of you remember who were there in the class. I mentioned that there is no need of installing Python fully into your system if you do not want to. You can straight away go to the Google Colab. So since I am working from office, it's not accessible, but you need to refer this link, just Google Colab. So when you click that, so I would be sharing this Python basics file with you as well. So this Google Colab has by default the packages installed, Python installed. So you can create a new notebook in your drive. So it's straight away saved in your drive. You can log in with your Google Gmail ID. I won't be allowed here since I'm office network, but you would be getting this is called as notebook. These notebooks are consist of tabs which you can just run it, and it would be as it is the way this Python Jupyter files looks it. So on a high level, this is a notebook called as Jupyter Notebook. So here these are tabs in which, those who do not know, in which you can write some syntax and you can run it. So I'll show you some example. So for example, if this is a tag, and I'll I can make add one more tab here. I can write something, for example, print hello, just for an example, and I can run it, and you will see the output below that hello. So these are different bars which you can run. So in this session, we're gonna understand basically basics of complete Python for now. If somebody wants to try it together with me, they can open Google Colab at their site. Maybe ask me to stop for a while if they want me to stop, or just understand today whatever I am doing it here, and then try to replicate the same notebook at your site. So I will share that. You can straight away upload it. So here are the options to upload your notebook. You can upload my notebook, and the same notebook would be uploaded here, saved in your Google Drive, and you can run the tabs. So it's quite easy to use working with the Python here. And we will make sure that all the experiments, all the machine learning programming which you're gonna do in future, that is this Google Colab itself would be self-sufficient to work on that. And this is how we worked with the last batch which I took. So Google Colab was sufficient. But having said that, if somebody wants to have Python totally installed into their system, just let me know. We can figure out one session or half an hour someday so that you can install it. Okay, I think then I should start. So is that okay, guys? Shall I start working with that, or you want me to stop? Somebody wants to go side by side. Just let me know
No,
once.
I think
Okay, so I think we are
I think
almost full house. So let's
yeah.
start. Okay. So, goal of this Python basics notebook is not to understand Python totally, but yes, as few of you are from C, so they have worked with C++ at some point of in our past work. So this is always gonna be the same, but even it's little easier to work on the Python. So most of the things would be self-sufficient for self-understandable. So let's do that. So we're gonna understand variables, how you declare variables in Python. Then we try to have some look of data types which is there. So basically there are a couple of data types. Int stands for integer, str stands for string. This is boolean, shortly called as bool here. Float, as you know, this is for numerics precision. And then there are some data types which are meant to store values, a group of values, like array stores a group of values. Therefore we have some such kind of data sets which are capable of holding multiple values. They are known as list, tuple, set, dictionary. uh, for C++, guys, dictionary is nothing but a hash map which you have used in C++. So this dictionary is sort of that. After that, we're gonna understand some basics operators which we wanna use in some point of time, and basic conditional statements and the loops which are prevalent in Python. And then we understand how to define a function in Python. We in C++, I think we use void in C, or maybe starts with whatever the return type of maybe return type of the function we use. But in Python is totally different and easier. We're gonna understand some functions. Then we also try to understand the file handling, because you're gonna read some data into the code, into the Jupyter notebook. So how you can just handle some files, read, open, write. And then basics of class. how the concept of oops principle, how to create a class, how to create the objects of a class, and then we are gonna understand a try except clause. And lastly, there is a pandas. This is a frame library and very very helpful at any, not just related to machine learning, in every area of work which you are working. If you are supposed to read data from CSVs, Excel as it is, or of even from very big data files, pandas library helps in that. So it's very easier to work with the structural data. So any data in the form of any form, normal file, normal doc form, CSV form, Excel form, pandas helps us do that. So this we gonna work. So in general, sometimes in the real time of work, we get data in the Excel form. So pandas heavily goes with machine learning work in terms of data IO. So this is very important. We're gonna read it lastly. Okay, so variables. Let's move this thing here. So this is a tab. For example, if I am at this tab, I have multiple options to create a new. If, for example, this is I need one more bar. I can just press code. So this is a code. For example, if I want one more tab here, I just press escape and blow. So we can get one more tab. So we will understand slowly. No issue. So now, okay. So let's say it's very easier in Python to declare the variables. So where one, where two, where three, where four. Here, earlier we know in some programming language we have to also declare that it's an integer. So maybe int where one equals to 100. But here in Python, there is no need of declaring the data type along with the variable initialization. It automatically tries to understand the nature of the data and accordingly give them the required or corresponding data type. So here you are see four kinds of variable. So where one is 100, 200.0, some string and a boolean, true false. If I want to execute this data type, I just have to press control and enter or alt and enter. So no issue. I will keep mentioning here to run a cell, press control plus enter. Eventually when you're gonna try, you will understand. Alt plus enter, right? So when I just do control plus enter, you will see a star sign here, and now its cell is executed. When it is star, it means the cell is running. Now where one, where two, where three, where four are initialized. And now to define run is similarly to the other programming language, is just print where one, where two, where three, and I just printed all four variables. So we get the values. So this is how we do normal variable initialization or variable declaration in Python. After that, now I want to understand. So let's do one thing. Just a minute. Okay. So wait. Now, now you want to see that what is the data type of this variable. So here the method which is used to find the data type. This is just type var1 and print on top of that. So basically print the data type of this variable var1, and subsequently I did it for all the remaining ones. And then we see these variables are nothing but int, float, string, and bool, and they have automatically taken from the nature of the data. This is an integer. This is a float. And this is a string, and this is a boolean. In Python, this is they are just defined with capital T, true. If it is false, it is capital. And whenever I use hash, hash stands for comment. So if I so this is a comment. So anything beyond hash will not be considered. For example, say I did it like that and I run it. You will see that error, invalid syntax, because true false is nothing. So I put it hash. This is a comment. So nothing would be considered. Now variable 4, this is the line it would be read by the interpreter. Now these are the four data types generally getting used, primitive data types. Now same example I tried to here in 10, 100.10. If we do it, same. This is a of type, data type of class integer, data type of class float. So automatically taken from the nature of the data. Okay. Now string is very string. The way if you want to define some string data type is very easier. We just define a string either with a single quote or double quote. So suppose I declared a variable, and as you must be seeing this syntax as well. So this is nothing. This is another way of having multiple line comments. So there are two ways. Suppose I want this is a first line. This is a second line, and I want to comment both the lines. Hash. I just put hash. So both lines are commented. But what if I'm writing some logic, and this is expression in the code. So I have to put hash everywhere. So this is not easy. This is not, I mean, time taking or little. Uh, what I can do, I just put three quotes on top and three quotes on bottom. So this is another way of commenting the code. Multiple line comment, right? So just put three, either double quote or single quote. So this is what we are doing it here. So this is a string. Now we define a name, variable name, string variable, and we put a string in it. This is a string. Now you can either use single quote or you can use double quote. Let's do it. So first remove that part. Alt enter. If I press Alt enter, and this cell would be executed and new cell would be appear up. So this is executed. I can copy paste it here. In notebook, it is okay if you just write print, or even if you write this way, this will also result. So this is a string. Even double quote works here. So it's up to you. If we do it this way, this is a string. This is how you can define string variables if required in Python. So so it's very easier. The way you write, the same type of data type would be assigned to the variable. And we just see integers, float, double, and then they are string, and then boolean, true, false, right? Another example of boolean, which I tried to take it here. This is bool var, the boolean variable. We give it true, and we try to print the type of it. So if I do it, you will see this is a class of boolean, bool. Similarly for false, right? So these are some class bool. So this is basic type of variable declaration. So this is how you can declare all the variables here. And it, for example, if a equals to 5, b equals to 6, both are integers, a plus b. So it's integer, it would be summed up here. So it's just that simple as that. So there's no need of writing int a, float b 6.0 and then sum up. No, it would automatically be inferred from the declaration. That is it. So this is very easier. Now that's okay. I mean, but in the real scenario, you would be working on data where you need to store data in array. So how we do that? So such kind of data types are known as sequences. So as name suggests, sequences are nothing but a continuous stream of data. For example, 1, 2, 3, 4, 5, 6, 7. We want to store this thing in. So how, and then later we want to work upon that. So how we do that? So therefore we will understand now second level of data types, sequence data types. In that we're gonna see first list and tuple. So array, I guess you all know how array is stored. The similar concept, sort of similar concept in Python is list. And as the name suggests, you already have worked with the list in C, C++. You must have heard of linked list, how linked lists work. But here the easiest part is that you do not need to create your own linked list and then store the values into that. That is automatically being done and can just used with the help of list or list this code. I'll show you how. So suppose I created a variable list var, and I just put it two up square braces here, right? List var. Now I just print list var here, list variable. Let's see it. What is there? So this is empty. Let's see the type of it. Initially, when you work with Python, just type some variables and try to understand their type, just to understand what data type it is. So this is a list. Now suppose I want to store 5 values in it. I can just use list var and I can put 1, 2, 3, 4, 5 here with a comma. Separated, always separated by a comma, and then this and this. Now you can see that a list variable contains 5 elements in it, 5 integers in it, which is 1, 2, 3, 4, 5. Now suppose this is list var. Try to understand this part. In Python, the indexing always, and somebody wants me to just stop at any point of time or want me to slow down, just let me know. Uh, in Python, indexing always starts with 0. By indexing, I mean to say uh, you want to refer 1. How we do it in array in general, we always call the 0th element of an array. So that is what called as index. So suppose I want to see first element of this list. So I will type 0. So it gave me 0th index. The 1 is placed. It gives me 1. Similarly, the index of 2 would be 1, 2, 3, 4. Let's make this example a little different. 4, 5. Okay. Now list var has 11. Now 21 is placed at index 1, 2, 3, 4. So if I place list 4, it would point me to the last element, 5. Now what will happen if I just put it 5 here, fifth element, the element at the fifth index. So as of now, there is nothing, no element is placed at the fifth index. Let's see what it will return. So it will give you an index error. List index out of range. 5 is not in the range. Range is from 0, 1, 2, 3, 4. So indexes ranges from 0 to 4. If you give any index beyond the last index 4, it would always be give the list index out of range. Right. Now suppose that's one thing. Now our list consists of 11, 21, 12, 4, 5. Now there are few operations which you can think of doing that. And the very basic we always think is to add some new item in it. I want to add some item into the list where the function is just plain. Uh, it's very easier. List where dot append. So here in this list variable append 6, and the append always goes to the last. So the expected output would be 11, 21, 12, 4, 5, and 6. So we run the append item and then we print it list where together. And let's see. So now you see the 6 is placed at the very last index. Now this index is at the fifth position. So that error would be gone. The fifth index, the 6 is placed. So this is how we keep on appending the element whichever we want. Dot append 9. So the append is always happens at the last index. So if we do that, that part is done. And if I print list file again, you will see the ninth is now placed. Right? Okay. So this is how we understand the very first array sort of data structure, which is capable of storing values into it. Now let's see one example before any questions. The best part is that this is list, which is a sequence data type, is agnostic to the type of data which you are storing. So it is capable of storing any kind of data. For example, I am a string. So you see that now the seventh index, a string is placed. So list variable is agnostic of the type of data which you are storing. An array, how it was, if you remember the arrays from C++ or C, how it was in from C++, that the type of element into the array has to be same. But here the list is, it's okay. It's just a pointer which is pointing to an object which is a string type placed in some memory. It is just pointing to that which I'm seeing here. So you can add or any type of data here of any type of data type, string, boolean, you can store it. So basically what I want to convey it here is that you can store any kind of data together or separate into a list, right? So okay, so guys, is list now clear to all? and and why the points which I gonna discuss in this Python basics, that's the something which you gonna use on the very first time you work on with the Python. So I assume the list is now clear. So if you summarize, anybody wants you to summarize what is list? A list is kind of a data structure which helps you store values into it, and these values can be of any type of data type. So it's just not that it has to be all integer or all string or boolean. No, it can store any kind of data in it. Okay, so we understand list. Now, best part of Python is that if I'm a new user, now I mean that's okay. Now I can just put explain me the list in ChatGPT, and we can understand all the things very easier. But there is a function defined by Python which is known as help. In help, this is a list variable which you already declared here. This is how you declare a list variable. There's one more way of doing this. I'm going to discuss this later. But list variable with double with square braces. This is how you define an empty list. This is how you define an empty list. Now, list variable is a type of list. This is understood. Now, I want to understand what all I can do with a list. So I just write help, and when I run it, it will say me that this is an immutable sequence as I mentioned, able to contains values. And the let's go a little down. That's not, yeah, you will see it has mentioned all the things which you can do it with that. I showed you append. So what append do? Append object to the end of the list. This is what it did, and we saw that. Clear. If I call list where dot clear, it removes all the item from the list. Count, extend, index. So there are many options. Insert. For example, if I want to insert the value some object, object means whether integer kind of values, string kind value, at some index it will place that. So let's do that. So for example, list where, this is how it looks like, but I put it insert. Even I do not know. I just see insert index 1121. I want to put some 100, say 100 at index number 0, 1, 2. So basically in place of 12, 12 would be moved ahead. Insert. Let's see how it works. Index 0, 2, some value 100. Let's see if it works or it fails. It's run. Let's run it. So see, the 12 is placed. Now 12 is placed in between. So now you can understand that, consider the linked list. You have placed 100 into here. All the elements would be moved one level ahead. So this is a kind of ON operation which you performed. So I assume, I mean that's okay, not required for this course, but you all have read at some point of time the Vigo notations, that how what is the cost of running some operations. So if you insert some item in between, it moves 12 here, 4 moved from here, 5 moved here. So you we shifted one element ahead. So this is an ON operation. But in append, we always put it on the last, which is an O1 operation, happened in just one computation. But that's okay. Computation is understanding. So this is how we can, whatever is required, can we understand with the help of help. Pop. If I want to remove the last element and return it, it will pop. We can use pop. For example, let's say, let's do it this way. And again, this is not something to be mugged up. It's okay. I'm just uh, showing you something here. Pop, and let's store it into X. So dot pop, when I called a pop, what it should have done, it should have removed the last element from the list and then save that value into X. So let's see X. Now X is I'm a string. So that I'm a string is should be removed from list var. And if I print list var here, it should be removed. So I'm a string is removed from here. So this is what pop operation does. Remove the first occurrence of the value. So everything is kind of easily explainable with the help of help. I want to reverse the string. Reverse is the function. Just call reverse list var dot reverse. It will reverse the string and list. Okay. So there are many methods available with these data structures, and we would be gonna use that whenever is required. Okay, understood. So if this is done, let's move ahead. Okay, now uh, let's define one more variable, list var 2. What I mentioned that this is how you can create a data structure of type list using this braces. But there's something already not kind of a old way of defining list with capital L. This I have not used for a very long time. This is not defined. Small l. Just a minute. Yeah. So not capital L, small l. List var 2. So it automatically defines a list, which is an empty list, and you can see it looks like a square braces. So this is how. Just a moment. So this is how we define list. So either use this or use this. This everywhere we use this. It's easier, right? Now uh, we see that in list var, coming to the older topic, this is 11, which is present at the 0th index. Now, what happen if I try to assign some value to the 0th index value? So what should do? Let's see that. So basically, we replace the value which is present at the 0th index with 110. So 110 replaced 11. Now it's 110, 21, and so on. So such cases, such data structures where you can change the value present at some index, they are known as mutable. They are mutable. I mean, which mean that you can mutate their value. By mutate, you mean you can change their value. But in some practical scenarios, which you're gonna see in future, there are some cases where it's not ideal to change the values, or the data structure should not be allowed to get changed by the user. So such thing is tuples helps in that. Tuples works as it is. The way list works, this is a immutable data type. So for example, and see how it is defined. List we see it was defined with square braces. Tuple is defined with the circular braces. So for example, 1, 2, 3, and comma. So let's see. Let's print that. I create a variable, tuple variable. Somebody calls this tuple, somebody calls tuple. So whatever sounds good to you. Tuple where is initialized with the circular braces. I put some values into it, 1, 2, 3, and then I see. So output is 1, 2, 3. And if I print its type, so again, as I mentioned, the way we do it for the tupware, this is a kind of tuple. Here I try to mutate a value presented the 0th index. Let's try to do the same thing as tupware. So tupware is here. So ideally, one should be replaced by 1000. Let's see. So it gives an idea. Tuple objects doesn't support item assignment. So this means this data structure is of type immutable. So once a value is assigned, you cannot mutate that. You cannot change that. So that's the difference between list and tuple. And one of the questions always asked for the freshers when they have the interview of Python as a Python developer, that what is the difference between list and tuple? So this is one data type. Now, third data structure, sets. Sets you already know. You have used set at some point of time. Set. So set is what? Set always gives you the collection of unique values. So for example, this is how my data looks like. Right. This is the data. Now, the funny parts of Python is that everything happens on just lesser code. This is square braces. Tuple is, I mean, the list is square braces. Tuple is circular braces, and sets are defined by curly braces. So once I define the set where curly braces starts, we provide some values into that, and now we try to print set where, and it gives you 1, 2, 3, 4, 5, 6. So basically, the unique values present among out of the values which are provided into that. So it creates a set of that. This is known as set. So 1, 2, 3, 4, 5, 6. We get the unique value of, and at some point of time, you would be working on the problems where for a time being you need to say create a hash lookup. So you have heard this term, I am sure, the lookup. So you have to look up that whether that value is present into the existing data. So if suppose these values are 1 lakh, so and we do not create a set of that, then what will happen? And we are searching x, for example, if x in that 1 lakh values, it will match one by one by one. So that's the huge computation. But if I create a set of that, and then if I search if x in that, that's little faster. So we need sets in real life to create some hash lookups, lookup tables. So therefore we would be using set. So set is kind of very understandable, as the name suggests, set of unique values, that is it. And again, for example, I create a set here. Now set can be created by set or the name. So it's always very easier in Python. If I want to create a list, I just say where one equals to list, where one equals to set, where one equals to tuple, and that variable would be initialized. Now uh, here it is written add, even but still if I do not know what are the methods, I can anyway call help. So where one, so I go down here, I try to find the required methods, and and we get the methods here. From it should be somewhere here, 2 bytes. Set is not well defined here. It means 2 byte from byte, new data, image, real. Anyway, let it be. So the way we see in the Python in the list, it was append. Instead, it is different. Either I can put 1, 2, 3 directly the way it has been provided here, or I can use the method add. So if I use add 5, it will add 5 into that value, and 5 would be added here. Since 5 is already here, let's try to add something else. Add 7. And since it is a set, you will not see double 5. You will see just 1 5. Let's do it. Now you can see 7 has been appended here because 7 was not present in this set. I tried to add 7 one more time. I press it enter, shift enter. No, it will the set will remain intact because 7 was already present. This is how we see the type of data structures. This is the third one. So we as so far we understand 3 type of data structures here to store a set of values: list, tuple, and list is the one which you're gonna use on a daily almost everyday basis. Even while creating the machine learning solution, you would be using list and set. So guys, any question, and again when maybe whenever you get the time on weekend on some day, you can just look read every cell from the starting and try to execute them. and try to see what is happening. So yeah. So guys, any question? Anybody having any issue with list, tuple, and set? So it's kind of very easier, but still, just let me know if it at all not making any sense, or if you're comfortable the with the way it is going right now. Anyone can speak up.
I think it's okay. Actually, I was just uh, I've logged into the Google Colab here and then trying to
Okay.
type those syntaxes. So since you were scrolling down and up, I could not
Okay.
completely
Okay.
get the syntaxes. Maybe you can share that notebook link, and then
That
I'm
would be
just
better.
practicing some. Yeah,
Yeah.
the
Sure. Sure.
Jupyter. I think it's a
Jupyter Notebook.
notebook which you have created for.
Yeah. Yeah. So I will share it later, and then you
Okay,
can just upload it and try to run each cells.
okay, yeah.
Yeah.
So,
Okay.
like one notebook here, mean it's like a one, let's say like program or what?
One notebook means the whole sheet which you are seeing it here. So there is
Mhm.
no end. You can create any indefinite numbers of cells, right? So it's very easier. For
Okay.
example, if I'm here, just need two. There are methods. There is plus sign. Insert a cell below. It will automatically insert a new cell. Insert a cell below. This is one thing. Or escape tab or B below. If I want to create a cell above,
Okay.
escape A. It's very easier,
Mhm, mhm.
right? So this way you can, or if I'm it here, if I press Alt Enter, it automatically execute this cell and create one cell bottom, right? See,
Okay.
so this is whenever I press Alt Enter, it will create a cell, also execute that. So this is very easier, because sometimes we work with VS Code here. Then you need to create multiple prints, and then in the when you run that VS Code, you will see all the multiple code coming up, printing up in the log. But this Jupyter Notebook is very easier to work, at least in the experimentation and the understanding, because you see the inputs
Mhm.
right away, bottom of that. So it's very easier. So when you Google Colab by itself is a notebook. This is notebook. So when you create a new notebook,
Mhm.
it would look as it is, like the way it is.
Mhm.
So it's very
Okay.
helpful. Okay.
Yeah. And second thing is like while indexing the list, you are using those square brackets even to index. So it, I remember I seen it as a the simple brackets like this these
This one.
curvy brackets. Yeah, for indexing, like let's say in list there are five elements. I want to index the like second element. So
This one. Yeah. For example.
yeah, yeah.
So yeah. So so indexing always is the square braces, right? So please index
Okay.
two. Do not get confused this with the initialization. In everywhere in Python, wherever, the indexing is always associated with the square
Square
braces.
bracket.
So yeah. So this is indexing and common for all, right? So that's okay. See, tab where 0 indexing is done in that way. However, you cannot assign values in the tuple. Tuple is immutable. Sets now we see. So okay, so far we have seen list, tuple, and set. Now we're gonna see one more important, very important data structure called as dictionary. Okay, so guys, you already have used this thing in the past. You must have you created hash maps. You have heard of the term of hash maps. Uh, so hash maps are nothing but dictionaries are nothing but key value pair. Key value pair. For example, I want to create a set of data set where I say, right, A stands for 0, right? If I want to create such kind of lookup, V stands for example, 1, so and so forth. Now, there in the key value pair, the keyboard, since as the name suggests, it's the key is always 1. There could be the cases that C has the value 0, may be possible, but keys always remain the same. That's the concept of key value pair, right? So if I want to create some data structure or some sort of data which follows this phenomena, I can use dictionary. And where it is used in the hash maps kind of stuff. So for example, dictionary, this is defined again. Do not get confused with the curly braces. Curly braces is just values are set in dictionaries. We define it with curly braces. We give them the key 1 colon value 1 comma second key 2 comma value 2. Let's define this way. So dict underscore variable or data type, object of dictionary data type of type dict, in short called as dict. Now I want to see what is the value stored for key 2. So it's very simple. Dictionary dict where key 2. If I print it, 200 is already present, right? If I want to add a new value here, new key, dict key 3. So it's very easier. Dict where key 3 some value, right? If I print it now, key 1, key 2, key 3, key value pair is added. So maybe you can think, or anybody get an idea, you can think some sort of area where this is quite useful. So one example I can quickly give you is that again a lookup solution you are creating, where first you check whether that value is already received by me, present in our data. We look up in this dictionary. If not, we add that value into the dictionary. So this way you can create a hash map. That value is present. If present, we check it from here, return the value. If not, we can add that. So in that scenario where you want to create the lookup tables, the dictionaries are quite useful. And lately you're gonna see the some real examples. For example, key values, the values are mutable. So key 3 earlier value was 300. I just put key 3 equals to 500. So now the key 3 is replaced by 500. So you will not see a new entry. Another key 3 equals to 500. No, because as the name suggests, key values, the keys are always unique. So key 1, key 2, key 3. Values could be changed, right? So this is how a dictionary variable look like and initialize. Another way of doing it is the same way we do it as a lick dict where, and we do it. Now initially it would be empty, but we can add. That's I want to create a set of A stands for 0, B stands for 1. Maybe we are solving some problem. And let's print. In a cell, if you write lines one by one, they are executed sequentially. First this line would be executed, then this line would be executed, and this line would be executed. That's why we see A equals to 0 is saved, B equals to 1 is saved. Right? So this is a data structure which is known as dictionary. In very simple terms for you, key value pair. If I want to store key value pairs, I can think upon a data structure which helps me storing key value pair. That's a dictionary. So a very simple example. So as of now, we would not be going very deep into the into each data structure because that will not help us eventually. So we keep think very simple, very basic. So far we understand what are the type of data types: integer, boolean, float. You all know how you initialize variables. Then we try to understand the three types of data structure: list, tuple, set. All are capable of storing multiple values of any type. It's just that list is mutable. You can replace the values present at any of the index. tuple is not mutable. Once value stored is stored, you cannot change that. And you can think that for many problems, many use cases, that's a very helpful data structure where once value stored, that's stored, you cannot change that. Now set, create the hash sets where you want to store the unique values. So then you create a set of that. Then finally another kind of data structure which helps us store the data in key value pair form, that's the dictionaries. So in C++, when we create hash maps are this is how the hash maps are stored. So hash maps, even the hash maps are created that way only. Hash map we stored value in the forms of int, for example, int and int. So this is nothing but key value pairs hash map. So we have int. So this int corresponds to key, this corresponds to values. So you can create hash maps there. Later in the future classes, when we work on the machine learning cases, we're gonna use dictionaries at some point of time. Then I'll bring this notion of how the dictionaries will come into the picture, when to use the list, and by the time all the classes would end, you would be having very decent understanding of when to use list and etc. Okay, now this is done. Um, so it's 8:24. Let's take 5 minutes break till 8:30, and then we're gonna start the conditional statements, basically the loops. You all have know the type of for loop is there, while loop is there. There's do while in some programming languages, but we just gonna understand the for loop and while loop. That would be very helpful. And then conditional statements, like if a greater than b, those conditions, how you can create condition statements in Python. We're gonna see that. Okay, then we also gonna see functions, and yeah, and some examples of functions. Okay, so anyone having any question before we meet up again at 8:30?
No, I think it's good to go.
Yeah.
Okay, then guys, okay, guys, let's meet up again in 5 minutes. I'll just put you guys on mute, and then yeah. Okay, are we back, guys?
Yes,
Okay.
I guess.
Okay, before we start, just a few questions, Gita. I After the previous lecture, I sent that lecture note, what I sent slide to the group. Did you guys receive that?
I mean, have you sent it via
So
the
I
email or?
via email. So okay, so via email on onto the group. I think there's a group in which you all guys are there.
Okay,
Just a moment. I did.
let me double check here.
Yes.
Okay, the
Hello.
hello, yeah,
Yeah. Uh, it's there.
is there? Okay, perfect. So I just want to ask if from the next classes I want to send some contents prior which you want to read. So is that fine if I send it onto that mail, or is there any Teams channel where
Yes,
among is there any team channels? Okay, but that would
yeah,
be
there is a
helpful
Teams channel, but you can send via email actually. This
via
email is
email.
now available. Yeah,
Okay,
yes, yes,
understood.
yeah. I missed to see that. There, yeah,
Okay,
it's there in the inbox.
understood. Okay, perfect. Hmm. Okay, let's start. So coming to the conditional statements and loop. Let's make it a little bigger. Sure. Okay. Now, mm, there is some we want to create some loops. Eventually what happened in reality, we do not never save values into some array or list one by one. We iterate over a series of data via loop, and then we do the operations onto those elements. So here, for example, I want to print, or basically I want to say print or just read some values from 0 to 50. So this could be done with the help of range. So it's very useful. So for I in this is how a for loop works. So it's very easier. For I in range, it's a syntax, general syntax, colon. So normally we see in other languages how it works. We uses braces to create a function, something. But here in Python, the very specific is that you use a colon and then you use a tab. This is how you make, for example, in C++ somewhere, uh, we create some function and then we create curly braces, we write something inside that. But here, just for I in range, it says that for a range of 0 to 150, one by one the value assigned to I, colon, tab, we always do it via tab and print I. So if I do it, you will see that the values are printed 0, 1, 2, 3, 4 till 49. It's always consider 0, the last element is out. So this is how you can print the values. So just make it smaller. So 4, 0, 1, 2, you can print that. So range basically does that. So if I just create so range 0 to 5, this is created. This is iterator whose values can be iterable can be iterated from 0 to 150. Now here, this is how you can use a for loop, a simple for loop. For example, if I want to read values from 0 to 100, or say 0 to 10, for I in range 0 to 10, print I. Right. So you will see the values are printing 0 to 9. Very simple. Now let's bring if statement inside that. It's very simple. I want to now, I want to see I want to print all the elements which are integers, which are even, and which lies between 0 to 30. So simple. For I in range 0 to 30, this is mod operation. You all know if mod is equals to 0 means divisible by 2, I print the value. The point to be noted here is that after colon, we create a tab. If I mod 2 equals to 0 colon tab. So this is how a statement will work. It will iterate. First 0 will come into the I, 0 mod 2 is equals to 0. Yes, it will print I. So it will print all the even numbers, say 0, 2, 4, 6, 8. For the cases where the mode is not 0, it will remove that, basically odd numbers. Now see some example of error. If I forgot to give a tab here and this is how I printed, then it will give me error that indentation error. Expected an indented block. So by indented means in Python anywhere when this block would be considered, print I would be considered inside if only and only if it is given by a tab or four spaces. I will always suggest a tab. So this means now this is a block. This together is a block, and after every column, this has to be indented. By indented means give a tab, and we run it, and you will see this is working fine. So, so here we create a four and simple one condition of double equals to, and this is how you can print the even numbers. So we understand how a for loop works, how a simple if statement works. Now take another example. The same thing. Now I want to do the same thing with a while loop. So see how how it will change. I initialize I equals to 0. Now condition is that while I less than 30 colon indented, if I equals to 0, print I, and you all know why we have to move I when I equals to, this is nothing but I equals to I plus 1. This is how we do that. See 0, 2, 4, 6, 8. So initially I is 0, it checks condition while 0 less than 30, 0 not mod is 0, right? Print I, increment I, and then again the flow goes to the while. Here in the for loop, we do not need to do I equals to I plus 1 because already we have created a range of 0 to 30. Values are coming one by one. Initially I equals to 2. If I equals to 0, if 0 mod 2 equals to 0, print 0. Then where 1 comes to I. 1 mod 2 is not 0, it won't be printed. 2. Now value 2 come added up into the I. 2 mod 2 is 0, print 2. Likewise. So it's quite understandable easily. Now see, now I try to mix item list. Now let's do one thing here. This is my item list, which I've already seen it here. I want to print all the items inside this list. How I can do that? For it could be I or X, whatever. I looks easier. For I in item list, right? Colon by itself. When I press colon, press tab, it will indented. So repeater notebooks takes care of that. Print I. So see 1, 2, 3, 4, 5, 6, 7, and 9, 10. This is how we iterate over and list. Now I give you a question that given the 10 elements, same, just print all the elements which are divisible, which are odd. So what I'll do for I in I, if I mod 2 not equals to 0, colon, indent it inside. So basically just 3579. We got the 13579. So this is how you can run a for loop over the list, right? This is how a list can be iterated. By iterated means you can move, you can bring an element, it comes to I, check with I, and you can just use all the elements one by one by one, right? Now taking one more example here. Ideally, the range function is little more. The range function always starts, it says that it starts with 0. This is a starting range, ending range. There is one more thing called as here the skip gap. This says that if I place 2, then it will skip element twice. So see what happened. So this is the full syntax of a range. See, it will automatically do the skip the range in between. 0, it skip 1, next value 2. Skip 3, next value 4. So this is what 2 is doing that. By default, it is always 1, which happens in that case when you print. So we do not skip by itself. But providing this third element, you can skip whatever you want. So see, 0, 3, 6. We are skipping by 3. 0, 3, 6, 9, 12, 15. So this is a complete formula of range, right? Print I. Now let's see an example. I want to now understand the use of where, where, list, and for loop. So I give you a question. Uh, Create a for loop that sums all the item, all the elements present in a list. So okay, so this is a question, and now we are given list 1, list where equals to 10, 20, 30, 40, 50. We are supposed to run a loop onto a list, and we need to sum it, basically just 10, 20, 30, 40. How we can do that? So first of all, just it's quite very, I mean, it's easier just doing it for the sake of making things complete. I define a variable initialized with 0. Now I run a loop again for I in list where what it will do, it will take value 10 into I. What I want to do, where 1 equals to where 1 plus I. Let's name it some good name, well, right? So we get the sum of all the values. What is it happens exactly? We define a value where 1 equals to 0 to store the sum into where 1. For val in list where we iterate over 1 by 1 by 1, val equals to 10, then where 1 initially 0, 0 plus 10, where 1 becomes 10. Now 20 comes here in val, again we add 20. So then what is exactly happening? 10 plus 20 plus 30 and so on. So this is how you can create a variable. You can create a for loop. You can do some mathematics operation. Now this syntax is again, I commented it, can also be written as in, like this way. So this is same. This is just saying that in the where one, add val and update the value. So this is how it happens in Python. Results gonna be same, 150. So either you can write where one equals to where one plus val, or just write where one plus equals to val. It's same as this thing. Okay, guys. So this is how, this is how we see a use of a normal variable declaration, a for loop, and simple aggregation function which we created, and we can do anything with the help of a for loop here. So this is how we work with the for loop. Now in when we work in the future, we would be using for loop to create some analyze some data, retrieving the values from some list, doing some operations, etc. So we gonna see that, but just for as of now in the present basics, you just need to understand how a for loop works. So you just practice how simple for loop works, because this is very different for other programming language, because they, we need to take care of the colon followed by the indentation. Even suppose even I just put it one space back, so this might give that, I'm not sure. Jupyter takes care of that, but not, so here Jupyter takes care of that. But for example, see, just doing something to show you how this matters. Well, again, see, so here in Jupyter, in Python, indentation matters a lot. These two are not on the same level, so they will always give you an error. So it's always make sure that they are tab separated, tab and tab. Now if I do that, irrespective of whatever the we get values, this will not throw an error. So this is passed. Always this has to be on the same indentation level. So this is the only thing needs to be taken care of Python. Instead of curly braces, colon is the one. Colon makes sure that everything which you do it, that happens inside the for loop. So we always need to indent it. Okay. But once you done do it a couple of times, it would be just very easier. Okay, so this is done. Now after that, let's now try to understand some basic functions. So just so again, we will not go deep into that. We will try to see how a function is defined here. Okay. Now, suppose I want to create a function. Let's not go it here. Okay. Somebody gives me a problem. Create a function which and I which adds a value in the list. So basically, what I am trying to, we will try to do it here. We will just try to replicate whatever the thing which we do with the list. In the list, you remember, uh, we in the list, if list one is a variable, I want to append something. We do it this way. Let's create a function which do exactly this thing. So I definitely create a def. In Python, you create a function definition starts with def. In C++, how you do that? We create int. If the return type is int, we use int, void, etc. But in Python, it's always same. The function definition is just definition, short form def. It starts with def. Then there comes the function name. It could be anything. So I name the function add element in list. This is my function name. Anything. Braces some well colon well list one. I'll complete this. List one dot append well return list one. Then I'll explain this thing. Okay, so we created a function add element in list. It contains two values. It arguments list one and well. What we are doing, we are appending that value in list one and return the list. Just one example. Now we press shift enter. The function is defined. So let's create an some list where empty list where this is required. Now we call the function provide the list where, because list one is the first thing, comma some value, say 10. Since it is returning this list one, let's store it into list output. Do that. You see the list output, it returns the list. It returns the list. We created an empty list inside that. A value, well, value 10 is stored into list where we return the list one. So this is how we create a simple definition function. Now suppose I want to create a function which do summation of two numbers. Add two numbers. This is, suppose this is the name. So it expects two number a comma b. Simple. C equals to a plus b. Definition return c. And uh, irrespective of what naivety we are doing it here, it's just that I want to show you how the function definition works. So it takes two argument a and b. This is a function name defined by def. Always we do the summation of that, take stores the value into c and return c. That's it. Now we add two number, say 10 and 20. Say output x, print x here. So 30. So this is how we created a function which adds two number. You can write a definition def add number. For example, if I want to create another one more function, The idea is that in general, the syntax will always be def. If I mention the function name, it expects the function name here. Then it expects arguments here. I'm just trying to make the things easier. And then here comes the function body, whatever you want to write. This is a simple thing. If it's up to you, you want to return something or no. So for example, here in this scenario, I do not want to return something. I just want to print C. So if I run add two numbers, same thing here, it will straight away print 30 because it's just we return it. The point to be noted here is that the body of defining a function, right? A simple example so I'll do that. Now we want to create a function, read element one by one from the list. If it is divided by 3, insert into another list. This is what we want. So goal is that you would be provided a data array in the form of list. If this number is divisible by 3, so here basically 3, 6, you need to put these elements to another list and return the list. So simple. We write the def function name, expected argument, item list, whatever. Since we want to store it into another list, we create an empty list in it, new list. The item will be stored all the 3 divide number in it. So now for I in item list, we iterate. If number is divisible by 3, we put that number into new list and return new list. So let's see. Item list, we run the function. You see the values are 3 and 6. So this is supposed to be returned 3 and 6. So this is a good example of function. Everything is same. We start with the definition, some function name, arguments. These are the comments. I already told you with three double quotes. Whatever you write it to we make it more understandable for the user. Uh, Now it is colon, so this is already tab indented. We create a new list equals to empty list. We already see that. We try to understand the concept of for loop here. We iterate over the item list 1, 2, 3, 4. We check if the I means 1, 2, 3, if divisible by 3. If it is divisible by totally by 3, we put that element into the new list by append, which we already have seen. And finally, when this for loop function is done, we return the new list. So once we call this function func1 provided this item list here, into that it returns the where. Now you already see that new list is a list. So even by chance, if I try to find the output of the variable, it would be list. It should be list actually. That's the list. Well, this is what we returned. New list. And new list was what? Empty list. Finally appended by some of the values which were mode 3. So this is how we gonna use this function in future. For example, suppose we are working on some structural data and we want my data contains some string values, and there are data such that I need to clean it up. For example, some data has missing values, some has multiple spaces on as a prefix, or some has spaces on the right hand side. I need to clean that column. So I can create a function and then apply that function onto that column. So what that function will does, it will remove all the spaces, basically trim it from left, trim it from right. Right. So we can create some ad hoc functions. So there the functions will be useful. So this is a simple way of creating functions in Python. Just basic def word, function name, arguments, do whatever you want to do it here, and finally return a statement if you want to return something. So this way you can create a function. Okay. Now coming to the okay. So guys, any doubt in functions or the definitions of function writing? And again, when tomorrow, whenever you do it by yourself for the very first time, these things will start making sense. That's okay. I just want you to understand since whoever having the first understanding of Python in this class, I just want to say that Python basic functions are quite easier, very easy. It's just few attempts. You need to do it a couple of times with over the Jupyter notebook, and things will become easier then. Okay, now one more concept we're gonna see is that list comprehension, and this basically comes. I should not do it right here, but this comes onto some little intermediate side of Python when we are quite okay with using function list. So for example, I have the item list here. Again, let's make it 1 2 3 4 5 6 7 8 9 comma 10. Right, I already showed you that if I want to print all the items which are even, what I did, I just create for I in item list. Right, I want to store it into a, basically the thing which we do it here, iterate over the item list and return all the elements which are divisible by 3 into a new list and return the new list. Now this is how a proper Python function works. But Python, what they did just to make things actually Pythonic, they make it more again one liner sort of stuff. Same thing here. If I want to do it, what I can do, 1 minute, let's move this line. So I already mentioned you that in Python, we see that if you want to define a list, it is defined by this double braces. Now the funny part of Python is that here, if I write something, it starts, it will automatically return the answer as a list. See, now I again told you how to, will tell you how to read it. For I in item list, where my item list is defined somewhere here, 1 to 8. If this I is equals to 0, return the I. Now this I which is getting returned, it is already being coming inside a double square braces, and you see this is the answer. For example, I name it var list 2. So eventually you all would be doing it later in this way only. I mean, you will start, so this thing will start easier then. Var list 236. Now how we read it? It's very easier. Now suppose it's very easier in terms of reading. I put it double quote as a comment. This is how it was written it here. Let's break it. For I in item list, see, now always a simple, it's very easier. This is what we have done. This is what actually for loop works. For I in item list, if I equals to 3, return I. So this is how it is written it here. For I in item list, if I equals to 3, return I. Whatever we want to return, we put it in the front. It is just that easier. Now if I want to see create a new list which is divisible by 2, so for I in item list, if I equals to 2, return I. So this is the part which is getting returned. This is the whole for loop thing, and this thing is called as list comprehension. So let's stop it. Let's remove this part. This is a comment. See, 2468. So the this way of style, this style is known as list comprehension. Basically, within a list, you write some code which eventually stores the answer, the return item, as a list. Now you see this is a one-liner way of doing it. So the whole function which you do it, the function, basically this is the same thing which we did for I in item list. If I equals to 3, we add that item into a new empty list which we define here. Same thing is here. For I in item list, if I equals to 2, return I. So that's just I, no need to mention, right? And we already doing it within double square braces. So that answer is stored as a list, and you can see that 246 set. So this is what is called as list comprehension. So when you reach this cell, I want you to practice a couple of list comprehension. You can just ask Google ChatGPT that provide me some examples of list comprehension, because this is a very easy way of doing some basic manipulations which in which we do not need to write a function. But that's totally okay if we do it by some functions, because this is what is necessary, the way of writing functions, and later you can understand the list comprehensions. So it's okay even if you do not understand, that's okay. I just mention it just to fulfill the whole usage of list. Now let's see. I want to create a function, a power function, which basically squares makes the just square it. So this is a function def function 1 x return x double star 2. It means whatever we provide into that 4, we provide 4 raised to the power of 2. So if I run it, you see that this is 16. Simple as that. If I do it 3, 4 raised to the power 3, which gonna be 64. Now this could also be do via one liner. Uh, that's okay if you don't understand. This is done with the function one liner function known as lambda x x colon 2. It says that I am a one liner function. Lambda is always one liner function here in Python. It says that you give me some value, I return whatever is mentioned here. Now my function is defined. Uh, uh, guys, now whoever please
ये बुक है
put yourself on mute. Okay, thanks. So see, this is a lambda function, very easier. Whatever we were doing it here. So instead of writing the whole body, we just write lambda x x raised to 2. It's very easier. It says that as a one liner function, whatever you provide me, I will do this thing what you mentioned on the right hand side. So I put it into a function object func. This is how it looks like. I am a lambda function func 4 the 16 func 5 25. So basically we create a one liner square function. That is it. Now another fun part, basically how we close for the day. Now I want to create a function which uses this lambda function and some kind of list, and it does what it does. It does the square of all the items present in the list. So here we gonna do that. See, this is the item list which we have 1 2 3 4 5 6 7 8. What I want to create a new list which basically consists of squares of these numbers. So initially I'll do it via for loop. Just to make things clear, this new list, empty list. For I in item list, just try to understand. I'll iterate over item list. What I'll do in new list dot append, what I want to append, the square of these numbers. So I 2, right? That is it. So what it will does, it takes value 1 2 3 4, it squares that, and after squaring append that value into a new list, and finally we see what happens in the new list. So this is method. So that makes them not too understandable. Shows ways to store the of squares of a list into a new list. New list. This is our objective. This is my list. This is method 1. Method 1, pure for loop, right? This is how we see. Okay, that is it. Now The 2. How are we going to do that? Via writing a function. So this is now. So let's do that. Def. Let's name it raised. I just name it some random name. Raised to power 2. Raised to power n. What it does? It takes a list one. So basically some kind of list. Here it is item list. Raised to. I want to raise all the elements to the power n. Right. So what we do? We create a new list, an empty list in which I want to show the value for I in list 1. What I'll do, the same thing, list dot append. What I want to append? I raised to power n. So we create a generic generic power function, and finally we return new list. See, you cannot return new list inside for loop. You cannot return new list somewhere here. You want to return new list only after for loop is complete. So once this is complete, you want to return just just below that. So these things we need to make sure. So this will come by practice. So this is a generic power function, right? Let's try to use this data function. Item list. My item list is defined already. If it is not defined, you need to create a new item list. Item list power 3. I want, let's see. So see all the numbers 1, 2, 3, 4. They are now tripled. 1, 2 raised to power 3, 8, 3 raised to power 27, so on. 4, 5. This is 5. This is 6, 7, 8 raised to power 3, 512. Now I want to return it to 2. 8, 6 raised to power 6. So we create a generic function, right? This is a power of a function. Now this is one way. Third way, which I just discussed before that, method 3, via list comprehension. So this is in the order, will be easy, will be easier for you to understand in the whenever you refer this thing. So I copy this thing here. This is a method 3. So for I in item list, I do not need if condition. See what I want to return for I in item list. What it says for all, for iterate over the item list, whatever the value come into the I return, or basically add I raised to power 2 here. So 149,613. This is with the help of list comprehension, one liner, but this is not generic. If I want to do it by 3, I will change the value here. Now it's raised to power 3, right?
Hello.
Mm, yeah.
So this list comprehension
Hmm.
means some easy way to manipulate the list. This is not exactly how function was. Correct? I means these are basically two different things:
The,
list comprehension and the function.
yeah, sometime what happen, we do not need we need something to be done impromptu. I mean just one liner, two liner, which is, so there is
Yeah,
no need of
correct.
writing functions, so we can do it right
Yeah.
away. But if that
Okay.
thing is meant to be done at multiple places, then we create a function. So list comprehension
Mm.
always to be done for simple things, not for a complex logic inside a function, right? Okay. Method
Yes,
4
yes. But this
with
is
the
the something like some simple method to
simple
manipulate the
methods,
list.
manipulate the list and store the value inside the list itself. So you are right.
Mm.
Method 4,
Initially,
lambda.
I confused little bit because I thought like this is like some alternative way to
Okay, but now I think
functions.
it's
Mm.
clear.
Now clear. Yeah, yeah.
Okay,
Okay,
it's
thank you.
just list comprehension. That is it.
Yeah.
Okay, now method 4, lambda and map. Map reduce, you have many times heard that. Map reduce. I'm gonna use lambda and map. So lambda, one liner function. We just show it somewhere here. This is my lambda. So I create a lambda function first. Just to make it generic, I use the variable n. Say n equals to 2, and I put it here. Now my function is there. Now what I want, I have already the item list ready. So let's print item list just to show you this is the item list again. Now my item list is ready. Function is ready. What I want, as the name suggests, I want to map this function func onto this list. So what I want, I'm just saying that hey list, use this function and let it get mapped on top of you. So once it is mapped, one will come here. It will return 1 raised to power 2 1. 2 would come here. So one by one each element will map to the function. This is what we do it here. Map function item list. For a time being, I remove the this thing. So this is a general sentence of using map. Already a inbuilt Python function, func, a one-liner function onto the item list. See, it will return a map. The values are stored at some location. You cannot see that what is inside that. You need to bring these values inside a list. So I just put it list. So see, all the values of item list got get mapped by a help of this lambda function. And this is something comes under the intermediate Python, but very helpful as a one-liners. So if I do it 3, let's rerun it 1 8 27 64 100 so on. Now this is tripled. So this is a fourth way of with the help of lambda map. So sometime when we would be working with machine learning solutions, we want to if my if from some objective my data I need to do some computation or data cleaning, and I know that this is just happening one time. I do not need to write a whole complex function. If something is doable with some lambda or this comprehension something, we can do that. But yeah, so this is one thing. Now uh, maybe last try accept. Okay, this we can see that. Okay, this we are almost at the end. There's one more function other than map. This is a filter function, and I think you all know that filter function, as the name suggests, it helps remove the filter out the value. Simple. Filter out the values as per logic. That is it. Logic is very simple. Is I create a lambda function. So basically, I want to create a function via which I want to filter out the values, remove the values. So my logic is that a function is that the mode is not 0. So basically, all the odd number sort of stuff is here. I force this function filter function. Instead of map, I use filter function name. Everything is same. Instead of map, it is replaced by filter. Function comes first, then comes item list, and we did it. So what it does, filter function is not defined. So let's define it, press enter and see. So it basically what it does, out of 1 2 3 4 5 6 7 8, it uses this function to keep the values. So basically filter out the values which are not selected by this function. So if I want to filter out all the odd values, my function is just to keep the even values. So I change this function. Now if I do that, all the values which are selected by this function that are selected, rest are filtered out. You know, the simple use of a filter function. But these would not be used that much, so that's okay. Just for the sake of understanding the Python basics, I have tried to use the map filters. That is it. But you should be well aware of how for loop works, the basic definition of Python, that we should at least have the understanding, and that is what I expect to that things to be taken from this class is that for loop functions, understanding of list for sure. You will hardly be or seldom gonna use tuple set. I'm not sure, but list you're gonna use almost on an everyday basis. So this is very helpful. Now coming to the last topic, try except clause. So basically, this is a try except block. You all know we do some functions. For example, let's understand this thing. I want to create a function. This is my objective. Given a list, find its reciprocal. So if you give me 2, I will return 1 by 2. If you give me 3, I will return 1 by 3. Right? We create a function list where find reciprocal. it expects a list. Then we create an empty list because we want to store value into that. We iterate here. Let's do it. Let me show you. Let's comment it. Once it is commented, it won't be runnable. Right. See, this is a simple function. Same as that. In this new list, just append 1 upon I, reciprocal. We create the function. We save the definition. We run it. Now see what happened. Everything works going well, but when it arrives to 0, 1 upon 0 is a 0 division error. So my program failed. So in future, what happens? You would be working on a lot of data. So and some of the data even not even you are not aware that where there are some issues with the data. Then we need some mechanism through which we make sure that if some wrong data appears up, that data is passed. Our program should not get failed. And this is available in all the programming languages. So you already know we use a try except block. So try except block. Now here the problem failed when it appears 1 upon 0, which is 0 division error. My code failed. So this is an issue. How we can make sure that this thing not happen. We're gonna use try except block. So how we gonna do that? So basically, in the list, we write a try except block. So for I list colon tab separated try, we do the operation which we want to do. Except when this code fails, the code moves to except new list dot append not possible. Now see written. So what happened? 1 by 2.5, 1 by 4.25, 1 by 6.16. When it appears 1 by 0, so what happened is when 1 by 0, it goes try, it failed. So when it failed, my code pointer moved to except block, and it what is just new list append not possible. So not possible appear up here. And then lastly, 1 by 10.1. So you see your code didn't fail. It just bypassed the error 1 by 0 is something here. Or I can write 0 division not allowed. Anything. Or this could I can return like this maybe 0 division not allowed. Or it's up to you. If it is divisible by 0, I can just plainly return 0 maybe as per the logic. I'm not sure. So just return 0. So see, so this is how a try except will help you work onto your code. Your code will not fail. It's just bypass the problem. Right. So this is how we can integrate a try except block anywhere. Is depend on building the logic. So you need to understand this how a try except work we gonna use at some point of time. Okay, guys. So I think finally let's try the last topic, classes. We know object oriented paradigm and we know how a class is work. So basically, mm, let's understand class in simple thing. Sometimes what happen, we create classes for such kind of data handling in which the data structures are already not allowed. For example, we have list, we have list, we have tuple, set, etc. But suppose I want to create a XOR function, a XOR class. We want to create a class which is capable of doing all the operations, and operations, or operations, NAND operations. This you have already heard of. So what we can create a class. Let's name it. Uh, I'm, let's name it operation functions once, right? So basically, I'll go on the code later, but see, 0 XOR 0 0. We created a XOR function here. Uh, so how we so how we do that? We can create a class of that. So in Python, when you want to create a class, you need to take care of the word class. Operation functions always starts with capital O. That's okay. And then there's a function called as init function. This is a constructor you must have heard of. This is sort of a constructor. Whatever is defined inside this constructor, inside this init function, that is called at the time of construction. We create a method inside that def and a and b for or. This is a symbol for NAND. We all know that NAND is not of AND. So A and B, not of that. Not is done by this function. This again not to be mucked up is just understanding. XOR is we created XOR function here, which is self or self NAND and end of that. So that's okay. So here you can see there are functions self. Self says that if I want to use this AND function inside the internal function, I cannot just use AND. I need to call it by self. Self dot AND, self dot OR. Finally, compute self comma a comma b, self dot XOR. We call this function. We create an object of that function, and just for a, now this is the use a double loop for a in 0 and 1, for b in 0 and 1. So what happened? Initially it takes a equals to 0, coincide takes b equals to 0. So 0 XOR 0. Then it takes 0 comma 1, 0 comma 1. And then it computes XOR gate compute a comma b. So initially 0 comma 0 value will come up into this compute function. Self dot XOR 0 comma 0. The XOR would be called then self dot and self dot or 0 comma 0, which is 0. Self dot NAND of 0 comma 0, which is 1. Now 0 comma 1 and is 0, and this is what it's done. 0 comma XOR 0. So you see, this is how we created a class which basically calculates XOR. XOR cannot be calculated directly. The underlying function is that takes an AND of or an NAND, but that's okay. But this is how a for loop works. I want to show you this part. Understanding of how to create an XOR is not important. How this looks. See, print a comma v, and see this how it looks. See, initially a is 0, then we go inside. B takes value 0. Print 0 comma 0. 0 comma 0 is print. A is still 0. B takes the value 1. Takes 0 comma 1. Then this is over. Now controls goes back to for loop. A is 1, B is 0, 1 comma 0. A is 1, B is 1. So we create a truth table. So this is how a nested for loop is work, right? But a simple thing needs to be learned here is that how a class is defined. Class is defined with a class keyword, class name, init function, and some internal functions method, and always associated with the self. Self is nothing, just to refer the object. So all the functions, for example, or is getting used here. So this is self dot or. That's okay. So for a time being, you can maybe if it doesn't make sense, just avoid the class for now. I'll take it later. But yeah, just whoever able to understand, this is a simple architecture of writing a class.
Yes, I still didn't get the this objective
Class.
of this class.
Okay,
It's
let's
why we
take
are doing this things.
okay. Let's take. I want to create an example here. Okay, let's take we create a class car, right? So I want to create a class of car. So if you able to understand, that's okay. If no, that's okay. So name, brand. Just a minute. This I should not have taken the example of XOR class. It's not right and initial. I'll replace it in the next classes. Okay. Suppose I created a class which consists of two values, attributes, name and brand. So my car one, C1 is the object. I make a car. I name it, for example, name is Swift, for example, belongs to Maruti. Another object of class car, whatever, some Merc, or say M3, BMW, for example, if M3 exists in BMW, not sure. Okay. Now two objects are created. Object C1, C2. C1 objects belongs to a car, which is Swift, belongs to a Maruti brand. Now if I use the C1 dot, this is a function I can call get car name. So you will see that it will return Swift. So basically, this is a data structure which is created specifically dedicated to a car kind of. So idea of class is that if I want to create some object oriented based data structures or classes where I want to do some operations and want to encapsulate that, I can use classes. For example, I can create a class of employee where I can have the init employee name, employee ID, employee designation, then get manager name, then the employee manager name would be written. So we can create a class of employee. So this way you can replicate the real behavior into a object oriented based programming. So classes, this can be achieved via help of classes. For example, banking payment solutions, we can create a class of payments where if you want to pay with the UPI, if you want to pay with credit card, debit card, what is the remaining balance, what is how much is withdrawn, all things can be created by help of classes. This is how you use a class, right? That's the example of some examples of using the classes. So
Okay.
here we created a simple
Maybe.
class. Mhm.
mm, So I'm little bit like aware about this, but the way we create the class that little bit confusing. So what I maybe remember from my
So
last
you
session.
you
So
so
this
you
get car
created
name
in
is
which
a
programming?
method.
These are
So
methods.
no,
These are methods,
these are the two methods. Yeah, the bottom
and
one.
this is the constructor. So you if you have done in C++, you define constructor, which is always the car name itself. Uh, so default constructor, but in Python, this is how it is. The class, the name of the class name, the constructor. So it expects
So
is
in
always
the first that first definition, we need to declare the properties of that class.
yeah,
Correct.
right.
This
Attribute
name, brand.
perfect. Yeah. So here you need to
Okay.
define the all the attributes. So these are expected attributes, or we call it variable. So for example, if I create one more class here and I do not provide it any, so it will fail. It is missing two required positional arguments, name and brands.
Okay, it
These,
is
these, these,
compulsory.
these are mandatory. Or if you do not want to give it compulsory, you can provide the default values. So that's up to us. But yeah, these are compulsories, right? These are, and so yeah, these are attributes, these are methods. So I think the only point to be understandable here is that how you define. So it's just use
Okay.
def
And here
how it.
in like let's say in definition where I'm defining the attribute in the self dot name, if you're saying that if instead of that plain name, if I mention some name, then it will be like by default values it will get set for any new object I'm creating, correct? So it will
Yeah.
not throw the error.
So sorry, could you please repeat your question?
So here you are saying like self dot name is equal to
Yeah.
name. Okay.
Mm-hmm.
So here if I give any name,
Mm-hmm.
let's say like Swift here itself,
Mm-hmm.
and brand like let's say Maruti here itself, then when
Mm-hmm.
I'm going to define the sorry, not define, when you I'm going to create new object at the line 156, like let's say
Mm-hmm.
C1 is
Mm-hmm.
equal to car, and if I don't give any inputs, then still it will not throw error. So because I'm already defined or given some default values to those.
Yeah, yeah. If default values is given, it would be taken. But then this is a kind of mistake you always need to take care of, the how the init method or your solution gonna work. Because in this
Yeah,
scenario, default values giving default values doesn't help,
yeah,
right? But
because
yeah, but
every
then every car would be say
same,
Maruti
yeah,
gone to
doesn't
Porsche
make
somewhere.
sense for a class. Yeah.
But yeah, so but our goal is to understand that they are attributes. Now see how self-help here. I forgot to mention self here, for example, and this is how I define the class, right? I call C1.
Okay.
Sorry, 1 minute caps is there. C1. See, the name is not defined. Name is not defined because
Mhm.
these methods doesn't know what his name is. They just know whatever is
Okay.
associated with the help of self, right? Therefore, it is essential to store the values in self.name. So if I do it there, right? So self is in self keyword always. So whatever is defined with the self, that is accessible throughout all the methods. So always use self.name. Never ever directly use name and brands or any attributes into the methods. Always use with the self keyword, right?
Okay.
Hmm. So take some
And
more complex
mhm.
examples and try to
Mm.
use classes with that.
Okay. Okay. I will try a little bit.
Yeah. And forever who wants to go deep into the class, I can write some more complex code of classes, but that is not required for now. So eventually we will seldom gonna use class directly into our machine learning use cases. But yeah, just for understanding, I have given a simple example. This is quite now. Now,
And
once you
here,
understand the car, you
mhm.
would be easier to understand this function. It's just that
Yeah.
I created an and
Mhm.
or and and so that is
Yeah,
it.
and here like method itself in function, correct? Means even in method I can encapsulate some what we can say, some logic or something, same like function, correct?
Yeah, yeah, yeah. And also I have not discussed how to attribute encapsulate them, assigning them
Okay.
private,
Mhm.
protected, or public. So it's just everything is public now,
Okay.
right? But yeah, okay. So finally, let's close for the day. This is how you define a class. You create a function which is a constructor. Always gets called when we create an object of class. This is how we create an object of class. C1 equals to car. This is the method which can then be called with the help of object C1 dot get dot get car name, car brand, so and so forth. Right. So guys, finally, we almost see all the basics of Python here. We understand variable. We understand some data types, int, string, boolean, float. The important one, data structures to store values in the forms of multiple, list, tuple, set, dictionary as a key value pair. I tried to add some operators here. Even some operators are used in that NAND AND function. Condition statement, we just see if and for and while loop. We hardly use while loop, so always try to stick always with the for loop. And then we see about list comprehensions, functions, maps, lambda. I have written for what sequentially. You can go one by one. File handling, I have skipped. Classes, a small brief. Try except clause, we see tomorrow or in the next, not tomorrow, maybe when we gonna do machine learning linear regression first problem by ourselves, our very first algorithm. When we gonna understand that, we're gonna do the experiment, and then at that point we're gonna use heavily the pandas. So eventually this point will come up. So I'll share this into the notebook with the mail. Whenever time permit, at least go through it once. It would be easier. Okay, guys. Okay. So now over to you. If any problem And also just do it one time, and I think this basics will start making sense. This is quite easier, so no issue with that. And even if you face some issues, feel free to you know discuss that in the next class. Okay, then we can close for the day. I'll right away send you this notebook. Okay then, guys, see you everyone.
Yeah.
Thank you, bye, good night.
Yeah. Thank you.
Thank you. Bye.
Good night.
Thank you.
Yeah. Thank you, guys.